Hi, I'm Mike Stanczyk and this is Digital Electronics Classroom. We're talking about Karnaugh Maps, and so we've talked about how to get Karnaugh Maps from a truth table, how to get a boolean expression from Karnaugh Maps, and then also looked at don't care conditions. In this video we're going to look at Maxterms from Karnaugh Maps. How do we generate a Maxterms POS configuration boolean expression from a Karnaugh Map? So let's get started. So Maxterms, or POS, from Karnaugh Maps. Alright, so let's generate a truth table. We got 0011 and 1010, 1100. 1010. Okay, great. And as per our rules, we're going to go by groups of 4 here. And remember, this one is the skip, and so we're always going to skip on these 11s. And so I'll write it in 00 skip 11, 10 skip 10. I kind of like to throw in that skip, help me remember. And then 11 skip 00, and then 10 skip 10. Okay, so that's what we have. So when we do Maxterms, first thing we're going to do is we're going to box zeros. Okay, so we're looking at boxing the zeros, and let's do that. So I got this nice group of 4 in the middle, and then I got a group of 2 over here, and a group of 2. Quick check, can I make these 2s into 4s? Nope. Can I make the 4 into 8? Nope. So we're good to go right here. The second thing I want to know here is that a Maxterm is the complement of a minterm. Oh yeah, and we're going to label this W, X, Y, Z. Perfect. What does that mean? That means if I look at these 4 labels, 00, 01, 11, 10, when we write out our expression for Maxterms, we're not going to write them as 0 and 0 or bar and bar. We're going to write them as the complement. So 0, 0 becomes 1 or 1. Because if we take the complement here, we break the line, change the sign, and so we got 1 and 1, and the sign becomes a plus. So 0, 1 is 1 or 0, and then 1, 1 becomes 0 or 0, and then 1, 0 becomes 0 or 1. So let's go ahead and look at building this expression then. So what I'm going to do is I'm going to pretend that these zeros are actually 1s and that we're building a minterm expression, and then I'm going to use this fact to alter it into our Maxterms expression. So let's look at this top left one. We can see that it's in row 00 and it's in column 0001. So I'm going to have W and X as zeros and Y as a 0. So we got W bar, X bar, Y bar. And so then when I transform it, it becomes W or X or Y. And so that's that transformation that we're going to do as we complement it into our Maxterm. Okay? Then we have this grouping of 4, which belongs to rows 0, 1, 1, 1, which means X is a 1, and columns 0, 1, 1, 1, which means Z is a 1. So this is X, Z. And then when I transform it, we're going to have X bar or Z bar. And these are ANDed together. And then lastly, we have this bottom set of 2, which belongs to row 10, which would be W, X bar. And it belongs to columns 3 and 4 here, which is 1, 1, 1, 0, which means Y is unbarred, it's a 1. And so we got W, X bar, Y. And that turns into W bar or X or y bar. And that is our expression, f. I don't know why I put f of x there, but there we go. Okay, just as a little recap, we build the truth table as normal, but now we circle the zeros, or we box the zeros. And then we understand that a max term is the complement of a min term. To make this easier for us to understand and use the procedures that we're already used to for Karnaugh Maps, we're going to write that as if the zeros were 1, we're going to write min terms for them. So we write these min terms for them, and then we do the transformation of a complement and from a min term for the 0 to a max term for that 0, which would then be appropriate. And so then we have the max term expression for this Karnaugh map, and we're valid for the function of the truth table and the Karnaugh map, what they define, and we're good to go. So thanks again for watching. Be sure to subscribe and like this video. Leave comments that I can respond to. You know, it helps make my day interesting, and I hope you found value in this. I'm Mike Stanzik. This is Digital Electronics Classroom. Have a great day.